Alrighty, so today we are talking about ellipses and conics. Johannes Kepler was one of the first people to describe his first law of planetary motion. He contradicted the idea that planets travel in a circle, but in fact they travel at an ellipse or an oval with the sun and that planet at one focus. An orbit cannot be circular, but rather is an oval shape. A conic is any section produced by that intersection of a plane and a right circular cone. And depending on the angle, it determines what it creates, like an ellipse, hyperbola, circle, or palabra. Today, I am focusing on an ellipse. An ellipse is a group of all points in a plane where the sum of distances of two fixed points is constant, basically an overcomplicated oval. Each point is called a focus, right here, and each ellipse has two axes of symmetry. The longer one is the major and the smaller one is the minor. Here we have the major, here we have the minor. Each part is a minor, or ish, it's like one. We'll get to that later. Alright, the endpoints of the minors are called the covertexes, and the endpoints of the majors are called the vertexes. So first, I'm going to find the equation for an ellipse at the origin. We're going to start with the foci. So the foci, once again, we have our ellipse, the center right here, foci, I'll label this as F, another foci here, and just think of this as a plane, just a normal grid, if you know what I mean, with the x-axis here and the y-axis here. And we have our vertexes here, or not our vertexes. Our vertexes here, and our vertexes here. So to find the foci, it's going to be negative c, 0, and c, 0. And c is just the distance between the vertex and the center, but we'll find that later. So once again, our origin here, if we're considering that this is just a regular plane, a regular grid, the equation for that would be x squared over a squared plus y squared over b squared equals 1. Now you may be wondering, what is x and y and a and b? So this equation is only used when the major is on the x-axis. So for this example, we would be using this equation. The only difference between the second equation is that a and b are switched. So we'd have x squared over b squared plus y squared over a squared. And this would be when we have an example like so. Okay? Now, to get more in-depth into that, let me erase all this. So, for when we use this equation, x squared over a squared plus y squared over b squared, a is greater than b. So, the major, to find the length of this, which I'll put my circle right here again. This is the, not this. This is the major because it's the longer one. It's like the fat part of the oval. To find this, you just do 2 times a. Not a squared, 2 times regular a. But once again, I'll get to that shortly. The coordinates of the vertices equal plus and minus a, 0. So as you see, a is a huge part here. Usually if they give you the equation, you're just going to plug all this in and in order to graph it. And the length of the minor, I don't know if we'll ever need to know that. Length of minor is 2 times b. That's just 2 times that. So basically, we're talking about graphing. The y-axis, I will make my oval here again. I'm gonna make my grid. Okay, here's my grid. Just a normal little grid with like the X, The marker sucks. Okay, let's try this again. Here. Okay, X and Y. Okay, so the major is once again the fat part of the oval. So my major is on the y-axis this time. So as I aforementioned, the only difference in the equations is that you switch A and B. So x squared, and A and B, these are numbers, and I will show you an example later. So x squared over b squared plus y. So I lost my voice there for a second. A squared equals 1. So just like when the major is on the x-axis, we have a similar setup for finding different parts of the equation and graphing it. Basically, everything is just reversed. So what is this? Okay, A is greater than B, so the major is still 2A. That stays the same, thank God. The vertex coordinates are going to be 0, plus or minus A. And the reason it's plus or minus is because they're on both sides. Okay? This time the reason it's sorry, I'm blanking here. Your major is on the y-axis, so you're going to be filling in your coordinate into the y, and then it's going to be on 0 because it's going to be on this here, but it's got to have one negative, one positive, because remember our vertexes are here. Okay? The minor is also 2b, and the foci is just reversed, 0, plus or minus c. And once again, the reason it's plus or minus is because you're going to have one foci here and one foci here. And to find c, c squared equals a squared minus b squared. This always stays the same. Now we're going to find these when given an equation. First, we need to determine whether it's one of these ovals or one of these ovals. The easiest way to do this is whichever number is bigger helps you know. This number is bigger, it's under x, so we know it's that kind of oval. Now that we know which equation we can use. So, the equation we're going to be using has the a first. X squared over a squared plus y squared over b squared. Now to find the major, we know that we're doing. Now we're going to find the minor. To find the minor, it's just 2b. Remember, this is not b, this is b squared. So we do the square root of 39, which is like 6.4 or something. So 2 times 6.4, I believe it's like 12.5. Alright, so that's our minor. That's just the length of, we have our oval that we're going to draw here in a second. That's just the length of our minor, okay? Now to find the vertex, it's going to be a plus or minus 0. And we have it in the x part because our oval is going to be a funny looking oval this way. The fat part is this way. So we've already found a. Fortunately, it's 8. All it is 8, 0, negative 8, 0. Now to find the foci, I'm getting up here. It is almost the same thing as this, except we are substituting in place of a, c. C plus or minus 0. We don't have c. Here I have an equation. This will always be your equation to find c. Regardless of whatever you're doing, just remember this equation. It's going to help you so much. What we do have is a squared and b squared. All you're doing is 64 minus 39 equals 25. So c squared equals 25, but we're not finding c squared, we're finding c. Don't get tripped up on that. C equals 5. So our foci are 5, 0 and negative 5, 0. Now let's graph this. Okay, so we'll graph our foci first since this is fresh in our brain. So let's do 1, 2, 3, 4, 5. And now we have to do on the other side because once again it's an oval. That's why we have our plus and minus here. 1, 2, 3, 4, 5. Alrighty, let me lengthen this out a little bit more. That was nasty. That sound. Okay. Now we'll draw our vertex. It's 8, 0 and negative 8, 0. 5, 6, 7, 8. I'll do it in a different way. Okay, 8, 6, 7, 8. And then now we just pause it. Okay, now we can draw our oval, but we need to find where our y-intercept is. B equals 6.4, that's just our y-intercept. So 1, 2, 3, 4, 5, 6, somewhere around there. 1, 2, 3, 4, 5, 6, somewhere around there, I think. And remember, these are our foci, but this is our, like the vertex where it connects, okay? Now let's draw our circle. Alright, and there's our oval. It looks good. We know that it's big parts on the x-axis, little parts on the y. You can also tell with your numbers. And that's how you graph when given the standard equation. Alright.